Now I'm ready. All right. So just post questions in chat. I'll check over and write them down in OneNote, and we'll just kind of go over it step by step. Shane will ask number 17. Number 17 says to convert each degree measure into radians. So we start with negative 40 degrees. In order to convert from degrees to radians, you want to multiply your degree measure by pi over 180, because there are 180 degrees in every pi radian. When you do that, the degrees cancel. So you're just left with 40 pi over 180. And I need to grab my calculator. And 40 over 180 is 2/9. So you have 2 over 9 pi. And that's your answer. Number 18 is the same thing, except instead of multiplying by pi over 180, you're multiplying by 180 over pi. So you have 3 pi over 4, and you multiply that by 180 over pi. This is just like stoichiometry. You're just using a conversion factor. If you do that, the pi's cancel. So you have 3 times 180 over 4. Which is 135. Number 7, number 7 says to factor r squared plus 3r is equal to 0 by factoring. You can do this a lot of ways. I would just take out the greatest common factor between r squared and 3r, which is just r. So if we take r from r squared, we're just left with r. If we take r from 3r, we're just left with 3. When the product of two things is 0, one of those two things is 0, so either r is equal to 0 or r plus 3 is equal to 0. So r is 0 or r is negative 3. Number 20 is asking to simplify that mess into something simpler by using the properties of exponents. So I think most of the properties are going to be used. The way I do this is to start up top in the numerator with that part. So if we do that, we want to multiply common terms. So 2 is a common term with 2. So if we 2 times 2 is just 4. Y is a common term with y cubed. So y times y cubed is y to the 4th. Because when we're multiplying things of the same base, we're just adding their exponents. And then x cubed is on its own. On bottom, we have a power of a power. So x squared to the 2nd becomes x to the 4th. Because when we have a power of a power, we're multiplying. So 2 times 2 is just 4. And then y to the 3rd squared is y to the 6th for the same reason. And we still have all that to the 3rd. Then we can simplify between the fraction lines. So 4 stays up top because there's nothing to cancel it down bottom. Y to the 4th over y to the 6th is y squared down bottom. And then x cubed over x to the 4th is x down bottom. And then all of that's still to the 3rd, so then we have a power of a power again. So 4 to the 3rd is just 4 to the 3rd. X to the 3rd is just x to the 3rd. And then y squared cubed is y to the 6th. And that's as simple as it can get. So the 2 or 3, I guess, main properties we use were power of a product, so if you have a product of two things and they're taken to some exponent, that exponent just distributes to each one. Quotient property. You just subtract the exponents. And then the product property, where you're just adding exponents. On number 13, we're asked to find the length of x, or the length of the missing side. So on these, you have to determine which sides you have, use that corresponding trig function, keeping in mind SOHCAHTOA, and then evaluating for x. All right. So here we have the adjacent side, which is x, and the hypotenuse side, which is 2. And the one trig function we know that has adjacent and hypotenuse is the cosine. So cosine of the given angle is going to be the adjacent over the hypotenuse. In this case, cosine of our angle, which is 75, is equal to x, our missing side, over 2. In order to solve this, just kind of pretend that this entire thing is one number. So we have to multiply both sides by 2, which gets x by itself. And honestly, I'll probably just take this as a final answer. You don't have to get much further than that if you want to. The cosine of 75 is like 0.258. And there's a bunch of decimals after that. And if you multiply that by 2, we get 0.518 rounded up. $15 is kind of the same problem, except our unknown in this case is our theta, and we're given every other side. So 15 gives you a triangle that looks like this. This side is 4.1, this side is 2, and this is the angle we're trying to find. So in this case, again, determine which sides we have. So 2 is the adjacent to our angle, and 4.1 is the one opposite our angle, opposite our given angle, theta. So I'm gonna use a different color. The trig function that we know has opposite and adjacent is the tangent. So tan of some angle is equal to the opposite side over the adjacent side. In this case, we know both the opposite and the adjacent. So the tangent of our angle theta will be 4.1 divided by 2. In order to undo the tangent, so in order to find theta, we have to take the inverse tangent of both sides. And you don't have to show this step, but this is what's happening. That inverse tangent cancels the regular tangent, so we're just left with theta. And the inverse tangent of 4.1 divided by 2. Again, if you get here, you're going to get full credit. If you want to keep going, you do second tangent 4.1 divided by 2. And you get 63 point, we'll call it just 64. So that's the measure of this angle theta. So this isn't too difficult if you just remember that inverse tangent undoes tangent and gets theta by itself. So if there's no other questions, I actually printed out, or not printed out, I made just a regenerated practice test, which would be something very similar to what you would see. The first 2 questions are the same, so as long as you know how to add fractions and do order of operations, we're just going to skip those. But Alec wants to do 19 first, so let's do that. So 19 is, again, just using properties of exponents. Think order of operations when you do this. So I'm going to simplify everything in parentheses first. So b squared times b to the negative 3. That's b2 plus negative 3. And then there's a 2 in there too. And all of that is to the second power. You can simplify that though to make it less complicated. So that's 2b to the negative 1. And then we're dealing with this exponent out here, which distributes the negative 1 and the base of 2. So you have 2 squared and b to the negative 2. And then b to the 4 just stays down there. Once you get here, negative exponents always switch sides of the fraction line. So then we have 2 squared on top by itself, and then b to the 4th times b squared, which is 2 squared over b to the 6th. That's your final answer. So this b to the negative 2nd in this step goes down to the bottom of the fraction line and then becomes positive. Yeah, they are saved. It should actually be up like right after we finish. I think it'll definitely be up tomorrow morning. There were a couple of geometry guys that were watching it right before their test, so yes. He can also, I uploaded this entire thing. One, I uploaded it to On Campus, and two, I emailed it to everyone. So if he can't make it to this, he can always look at this. This has all my notes, how I'm going to grade it in red, and steps that I would do. So that's kind of the next best thing. So again, if there's no other questions, I've got a regenerated test that I'll just kind of walk through. I'm not going to do 1 and 2 because those are the same ones as the practice test. They should be. Yeah, I mean, these are the regenerated ones, 11 and 12. Which I guess we can just do. So 1, 1 minus 6, negative 6. It's really 1 minus 6. And then the second element is 1 minus a negative 6. So you simplify both of those. 1 minus 6 is negative 5. 1 minus a negative 6 is positive 7. And that's your answer. That's all I'm going to ask. We'll get to harder stuff later on in the semester, but that's it for now. As long as you know how to do that, we're good. Number 12, it's the same thing, except you're multiplying. So negative 4 times this matrix is negative 4 times negative 2, negative 4 times 6, and negative 4 times 3. then if you simplify that, it's just positive 8, negative 24, and negative 12. And that's your answer. It won't get harder than that. If anything, there will be like more elements, but it's going to be the same thing. So adding and subtracting, like number 11, you're just adding or subtracting corresponding elements. So 1 corresponds, so this 1 corresponds to this 6. And then this 1 on the right corresponds to this negative 6. And then you just carry out the middle operation. Since people had most questions about these last couple, I'm just going to start there. So number 15, angle theta, we're given the opposite and adjacent side. So tangent of theta will equal 4.3. Oh, just kidding. We're not given those sides. We're given the hypotenuse and the opposite. So that's sine. So sine of theta is equal to 4.3 over 15. You take the inverse sine of both sides. You're left with just theta is equal to the sine inverse of 4.3 over 15. And that's the answer. Again, you can simplify that if you want, but this is all I'm looking for. On number 16, you're given the adjacent side and the opposite side. So it's cosine, so cosine of theta will equal 4 over 8, or 1/2. So again, you take the inverse cosine of both sides, you're left with theta, and then inverse cosine of 4 over 8. And that's as far as you need to go. For 13 and 14, this time you're just given the angle and you have to find the opposite side. So we need to find the opposite side x. And we're given the angle on the adjacent side. So opposite and adjacent, that's tangent. So the tangent of 68 degrees will equal x over 10.6. And then as long as you treat this tangent of 68 degrees as one number and solve for x, then you're good. So you just multiply both sides by 10.6. And then you have 10.6 tangent of 68 degrees is equal to x. You cannot multiply this 10.6 by the 68. Those are two different things. So this 10.6 stays on the outside. And again, you can go further than that, but this is all I'm looking for. For number 14, kind of the same thing, except you're given the hypotenuse and the adjacent side. So hypotenuse adjacent, that's cosine. So cosine of 32 degrees is equal to 4 over x. So I would multiply by x and then divide by cosine of 32. I'm just going to do this in one step to save time. So then we have x is equal to 4 divided by cosine of 32. For that math, if that confuses you, we had cosine of 32 is equal to 4 over x. This x and this cosine of 32 just switch places. That's all that happened. So this x goes up here. This cosine of 32 goes down there. Conversion, again, this is easy. You just got to multiply by the conversion unit. So we want to multiply 360 degrees by pi over 180. You always have to keep in mind that these degree symbols or pi's have to cancel in some way. So these degree units cancel. 360 divided by 180 is 2, and then pi stays there. So 2 pi is your answer. For pi over 6, instead of pi over 180, you want to multiply by 180 over pi. This way the pi's cancel. And then you have 180 divided by 6, which is 30. Properties of exponents. I'm going to simplify inside these parentheses first. So we have 2v squared over 2 stays there. V squared times v to the third is v to the fifth. And all of that's to the fourth. Which leaves 2v squared up top, 2 to the fourth down bottom, and v to the 20th. 2 over 2 to the fourth is 2/3 downstairs, down in the denominator. And then v squared over v to the 20th is v to the 18th down bottom. For number 20, 2ab cubed squared is 2 squared a squared b to the 6th. Then 2ba squared stays there. Then we have to combine like terms up top. So 2 squared times 2 is 2 to the third. A squared times a squared is a to the fourth. B to the 6th times b is b to the 7th. Then we have a cubed, b cubed down in the denominator. To simplify further, there's no 2's in the denominator, so 2 to the third stays up top. A to the fourth over a cubed is just a. And then b to the 7th over b cubed is b to the fourth. Chef, what question do you have? I can go over any question you have, so just ask it. Yeah. 8 on, I'll just do it on this, because it's just another test regenerated. So we want to solve this quadratic by factoring. The way I do it, create the box, 4r squared goes up top, and then 3 goes down bottom. And then I'm gonna just try a couple, I don't know the answer to this. So I'm gonna put 2r up top and 2r on the side. And then that doesn't work though. So if I were to keep going, I'd put -3 here, -1 here. That's -2r and -6r. But -2r plus -6r does not equal -7r, so that doesn't work. So ignore that. Instead of 2r up top and the side, I'm going to put 4r up here and just r on the side. And then 3 goes in here, and then we want, let's say, -1 on this side, which gives us -4r. And then -1 times -3 is 3. -3 times r is -3r. And then -4r plus -3r does equal -7r. So these are our factors. This does say solve. So this isn't your last step. You have to set each of these equal to 0. And so 4r minus 3 is equal to 0. And r minus 1 is equal to 0. If you solve for r, 4r is equal to 3. So r is equal to 3/4. And then r is equal to 1. A lot of people think that the first guess has to be the right guess. It's not. You have to keep trying with this like algorithm in order to get the right answer. And eventually you do. And then you can always check this. So 4r times r is 4r squared. And then 4r times -1, that's -4r, -3r. Those add up to -7r. And then -3 times -1 is +3. So you would just FOIL out our factors. In order to check. But if you use this box method, it really shouldn't matter. Because you should get the middle term. So on this test, 17 and 18 are those questions. Converting from degrees to radians. I'll write it down on one note. If we want to convert from degrees to radians, there are 180 degrees in every radian. Sorry, there are 180 degrees in every pi radians. So you take the number of degrees you have, and you multiply that by pi over 180. And then you simplify this fraction. And then you have some smaller fraction, and you leave pi there. Alright, so the example on the test that I just printed, 360 degrees. So we would take that over 1, multiply by pi over 180. If you carry out this multiplication, this is what you get. And then you can simplify, right? So take common terms, so 360 divided by 180, that's just 2. And then pi is left over. It's kind of the same thing for converting radians to degrees. Except this time you have some number of pi. And you want to cancel out the pi, so you want to multiply by 180, divide by pi. In that way, the pi's cancel, and you're left with some number times 180 degrees, and you carry out that multiplication. Again, so our example is pi over 6. So we multiply by 180, divide by pi. These pi's cancel. Then we have 180 degrees divided by 6. If you carry that out, you just get 30. You're doing the matrix stuff that's on the practice test. So just 11 and 12. I'm not making you multiply matrix by matrix, or finding the determinant, or any of that. If you know how to add and subtract and multiply scalars, then you're good. So if you know how to do number 11 and 12, you're fine. I'm gonna quickly go over 3 and 4 because we haven't actually touched it at all. And number 3, you're given the slope, so you're given m, and you're given a point xy. And it's asking for the slope-intercept form of the equation. So we're given m, and we're given an x and a y. So you just plug all that stuff in. So 3 is equal to -2 times x, which is also -2, plus some number b, which we don't have. If you carry this out, 3 is equal to 4 plus b. Subtract 4 from both sides. So -1 is equal to b. Plug that into our original equation, so y is equal to -2x minus 1. On number 4, instead of just explicitly being given the slope, you have to find it. So in order to find slope, you take the difference in y's over the difference in x's. And I would label this one x1, y1, and x2, y2. So y2 is -4. Subtract -3 from that. x2 is -1. Subtract 5 from that. So -4 plus 3 is -1. -1 minus 5 is -6. So our slope is 1/6. And then you can just pick one of those points and do the exact same thing we did before. Alright, so I'm going to pick x1, y1. So we're given x and y, and we're given our slope m. So -3 is equal to 1/6 times 5 plus some number b. So -3 is equal to 5/6 plus b. If we subtract 5/6 from both sides, we get -23 over 6, which is b. That doesn't sound right. That's alright. And then we have our entire equation. So y is equal to 1/6 x minus 23 over 6. I'm not 100% sure if that's right, but that's how you do it. Number 5 in this case is a little bit trickier. There is no y-intercept, and the slope is always rise, never run. X is always equal to -4 in this case, so it's just x is equal to -4. Because no matter what y is, if y is +3, x is still -4. If y is -2, x is still -4. Give me 1 second, chef. I'm going to do one with the quadratic formula, and then we can do that stuff. Just because we haven't seen these. I've done those two twice. So number 10, a is equal to 7, b is equal to 0, c is equal to -4. Our formula is x is equal to -b plus or minus the square root b squared minus 4 times a times c all over 2 times a. If you plug all those in, x is equal to 0 plus or minus -4 times 7 times -4 all over 14. Which is equal to the square root of 112 over 14. If you simplify this, 112 is really 16 times 7. So you get root 16 times root 7 over 14. The square root of 16 is 4, so you have 4 root 7 over 14. And it's the positive or the negative version of that. That one's probably a little bit confusing to do because there's no b, and then you have to simplify this to 112. But if you make a factor tree of 112, you can get here. I just kind of save time. Basically, if you know this and you plug everything in correctly and at least get another step further, you're gonna get most of the credit. And number 9, you don't even have to, if you get a question like this on the test, don't use the quadratic formula. What times itself is equal to 9? So you just take the square root of both sides. So p is equal to 3 or -3. 3 or -3. We've done factoring. So we've actually basically done this entire test. Yeah. Alright, I will do 14 because we haven't done that yet on the actual practice test that I gave you. (14) gives you a triangle that looks like that. And it's asking you to find the length of this x. And this x, that's the hypotenuse. And this 2 is the opposite side. So this is our angle. This is the side opposite. And this x side, that's the opposite of the right angle, so that's our hypotenuse. And we want to find x. So the first thing you have to do is ask yourself which trig function has opposite and hypotenuse in it. Again, remember SOHCAHTOA. So in this case it's sine. So the sine of an angle is always equal to the opposite over the hypotenuse. In this case our angle is 57 degrees. Our opposite side is 2 and our hypotenuse is x. So to solve this, you're really not doing any trig after this point. You can make sine of 57 some decimal, but there's no point. So we need to get x in the numerator. So we want to multiply both sides by x. X over 1. That cancels these x's. And you're left with x times sine of 57 degrees is equal to 2. And then again, we want to get x by itself, so we have to divide both sides by sine of 57. Do that, these signs cancel, and you're left with x is equal to 2 divided by sine of 57 degrees. You don't need to simplify that. You can if you want, but sine of 57 is literally just typing in sine 57 in your calculator and getting some decimal, which you don't know what that means, so it doesn't matter anyway. So if you're able to get to this fraction, you're good. We probably have enough time for like 1 or 2 questions, so if there are any, now would be a great time to ask them. And if you want to go back and watch this, I think it should be available pretty shortly after I end this. Yeah, I can do 1 and 2. So number 1, that's just adding fractions. You have to get a common denominator from both of them. So I always just multiply by each other's denominator. So multiply 2 over 7 by 3 over 3, and multiply 4/3 by 7 over 7. Multiplying fractions, you always multiply across. So 7 times 4 is 28. 7 times 3 is 21. 2 times 3 is 6. 7 times 3 is 21. That guarantees that these denominators are the same. Alright, and once they are the same, you just add the numerators. So 28 plus 6 is 34 over 21. That's your answer. Really what I'm testing you on is, can you add fractions? In order to add fractions, you have to get a common denominator. So if you know how to do that, you're fine. Number 2 is all order of operations. So the first thing you have to do is parentheses. So 4 plus 2, that's 6. Everything else stays the same. Then you have to deal with the parentheses. So you have 7 times 36 over 6 plus 2. then you can kind of, as long as you're multiplying or dividing, you can go in any order. I would do 36 divided by 6 because that's just easiest to me. 36 divided by 6 is just 6. So you have 7 times 6 plus 2. And then you're just multiplying. So 7 times 6 is 42. 42 plus 2 is 44. Again, all my work has been emailed to you, at least for the practice test that I gave you in class. I think this video will be available like as soon as I close this. I'm not sure about that, but I think it is. Number 3. Yes. Hi, Bob. So we're given a point, 1, 5, and a slope of 3. So that's our m. Alright. We all should know this equation, y equals mx plus b. So you just plug in what you have. So we have an x, we have a y, and we have an m. That's what I'm doing. So if you plug all that stuff in, you get this. 5 is equal to 3 times 1 plus b. And then you only have one unknown, so you have to solve for that. So 5 is equal to 3 plus b. Subtract 3 from both sides. 5 minus 3 is 2. It's not a 2. Right? 5 minus 3 is 2. 3 minus 3 is 0. So all you're left with is b. So now we have a b, an m, and our equation. Put all this together, you get y is equal to 3x plus 2. Yeah, I hope I can actually do that. I'm almost positive I'm some kind of illegal, but that's alright. Last minute questions? Anything? I don't think so either, but I I don't really care. Graphing. I don't think I'm asking you to graph. Oh, I am. Huh. I mean, if that's the case, then it's decently easy. You just graph these 2 points and draw a line between them. I feel like that's pretty easy. It's literally, can you plot 5, -3, and -1, 4? -1, -4. So we can do that if you want. No, you will not have graph paper. I can add a graph though. I can do that. If I don't, then I'll just not have you graph it. Because I don't think I even, on my notes part, yeah, I didn't even include the graph. So as of right now, I'm not even testing you on that. That would just make those problems worth 1 more point. Yeah, I probably won't. I'm hoping to God that you guys can plot points. Then again, I also assume that you can add fractions, but that's alright. I don't know what that is. Don't Google that. You get some bad pictures. Yeah, I am hyped though. It's a good show. Alright, if we're just gonna talk about this, I'm assuming no one else has any questions. I'll wait another couple of minutes, but this has been going on for an entire block period. Okay. I'm gonna do one of them, and then I'm gonna call it. Oh, yeah. So number 11. Alright, children. When you're subtracting matrices, you're just subtracting corresponding terms, right? So this 1 corresponds to this 2. And then this -1 corresponds to this this positive 5. Alright, so if you do this, we have 1 minus 2 up top, and then -1 minus 5 down bottom. So 1 minus 2 is -1, and then -1 minus 5 is -6. So that's your new matrix. 12 is really easy too, and I'll just do it real quick. When you're multiplying a scalar, which is this -2, by a matrix, you just multiply everything in the matrix by that scalar. So you'd get 12, 6, 4, -8, -2, and +4. Alright, so -2 times -6 is 12, -2 times -3 is 6, -2 times -2 is 4, and so on. Yeah, it's that basic matrix stuff. I won't give you that. That's only for multiplying matrices, which I'm not going to do because people panic about. We'll do that later on. No problem, Bob. So again, all of my answer rubric is in on campus. It's also emailed to you. This video, again, I think will be up right after. And then you have the practice test on your own. Alright. We did a whole separate practice test on here. So this bad guy. We did most of it. We didn't do these two, but it's factoring. It's not that bad. We did everything else though. I'm not gonna put that anywhere, but it'll be in this video. So like you can use that. You can pause. You can write out questions. You can try and do it yourself. So at 9:15 I'm done, period. Is there anything I can get by then? You have like less than 2 minutes. thought about doing Twitch. Um, but if I'm gonna put videos on here for actual like class stuff, it's all in one place. It's easy to get to. Okay. Um, I'm done. I want to go to bed. This will be available right after. Again, I think I'm not 100% sure on that. You can always email me. I'll probably be up watching Game Grumps for the next 20-30 minutes. But yeah, we went over 2 tests, so I think we did a pretty good job. All right. Um, please bring a calculator tomorrow. Help yourself. I don't have very many right now, so come prepared. I'll face reveal tomorrow during class. I'll come in wearing a paper bag if you really want. But I'm done. All right. So I will see you guys tomorrow.